Hey everyone, welcome back. Today we're going to be looking at Click-Calib.
Click-Calib, yeah.
It's a pretty interesting new method for calibrating surround view systems in cars,
Right.
the ones with cameras all around the vehicle that give you that bird's eye view.
Right.
Super helpful for parking.
Absolutely. And it's not just for parking anymore. They're becoming so important for all sorts of safety features,
Right.
even for autonomous driving.
Yeah, it's really interesting how this paper presents this new method. It seems so much simpler than what we're used to with those traditional approaches.
Oh, yeah, definitely.
But before we get into the really technical stuff,
Yeah,
could you give us just a quick overview?
sure.
Why is calibration even necessary for these surround view systems in the first place?
Well, so think about it like trying to put together a puzzle,
Okay.
but the pieces are all warped or just slightly off.
I see.
That's kind of what happens if those cameras in the surround view system aren't calibrated properly.
So it's not giving you an accurate picture of what's around you.
Yeah, exactly. The system, it needs to know the exact position and orientation of each camera to be able to stitch those images together, accurately. We call those the extrinsic parameters.
Oh, okay. So if that calibration's off,
Right.
the 360-degree view that you're seeing on your screen,
Yeah,
it could be totally distorted,
totally.
making it really hard to judge distances and even miss obstacles.
Exactly. And it could even be dangerous. Accurate calibration is essential for these systems to really understand the geometry of what's around the car.
Gotcha.
Impacts everything from just, basic parking assistance to those more advanced features like lane departure warnings and things like that.
Right. Okay. That makes total sense.
Yeah.
So let's talk about the traditional methods for calibrating these systems.
Yeah.
The paper mentions how they can be really cumbersome,
Yeah.
involving special patterns and
Right.
whole setups.
Lots of setup.
Yeah. So
Yeah.
can you kind of walk us through that?
Absolutely. So the most common approach is to use those checkerboard patterns.
Okay.
You've probably seen them a lot in robotics labs, research. You have to carefully position these patterns around the vehicle, at specific distances. And then you take images from each of the cameras, and then the algorithm will analyze the images and use the known dimensions of that pattern
Right.
to figure out the camera parameters.
So it's kind of it's a geometry problem almost.
Totally. It's all geometry.
And you're using these patterns as your reference points
Exactly.
to solve for those unknowns,
Yeah.
which are the camera positions and the orientation.
Exactly. But there's a few drawbacks to this approach.
Okay.
First, those patterns, they can be really big and bulky,
Yeah, I was going to say.
which makes the setup you need a lot of time.
Yeah, it's a whole process.
Yeah, and sometimes it's just not practical, especially in tighter spaces.
Right.
And then second, the accuracy of that calibration, it kind of tends to drop off as you move further away from the pattern. So you're mostly limited to calibrating for the area that's really close to the vehicle.
Yeah, which makes sense why it's used in a controlled environment.
Exactly.
Not so much for, driving
Right.
out on the road.
You don't want to rely on a calibration that's only accurate within a few meters if you're, driving on the highway.
Right.
Yeah, exactly. And that's one of the areas where Click-Calib really stands out.
Right.
It aims to provide accurate calibration over much longer distances without needing those bulky patterns.
Okay, now I'm intrigued. Tell me more. So what's going on with Click-Calib? How can it get this accurate calibration without the patterns?
Well, it's actually pretty clever.
Okay.
It uses the natural environment.
Wait.
So all the user has to do is click on a few key points on the ground in the areas where the cameras overlap.
Wait, so you're saying just by clicking on a few points on the ground,
Yeah.
you can calibrate the whole system?
That's the idea.
That seems almost too good to be true.
It does.
How does that even work?
I know, right? It sounds deceptively simple, but there's a lot of math and optimization happening behind the scenes.
Okay.
Essentially, the algorithm takes those clicked points, which are essentially corresponding points in the images from multiple cameras, and uses that information to figure out the best possible camera poses that'll minimize the errors
Okay.
in how those points are projected into the images.
So it's like giving the algorithm a few pieces of the puzzle, and it has to figure out where all the other pieces go based on where those first few pieces are.
You got it.
Okay.
And what's really cool is that it doesn't just work in the area right around the car.
Huh.
It can stay accurate at distances over 10 meters,
Wow.
which is a big improvement over a lot of the traditional methods.
That's really impressive. I do have one question, though.
Yeah.
What about when the ground isn't perfectly flat? wouldn't that throw off the calculations?
That's a good question. The researchers actually tested that.
Oh.
They looked at Click-Calib's robustness against ground unevenness. They even simulated like slopes. Oh, wow.
And random noise, just to see how it would perform.
So even if you're driving on a bumpy road or like up a hill, Click-Calib can still give you an accurate calibration.
That seems to be the case, yeah.
Mm.
The results of their tests show that it's actually surprisingly robust to those imperfections. They used something called the International Roughness Index, or IRI,
Okay.
to simulate all these different levels of road roughness. And even with all those bumps and dips, it kept a good level of accuracy.
That's pretty amazing.
Yeah, it is.
So it sounds like Click-Calib has like a lot going for it. It's simpler,
Right.
faster,
Yeah.
more accurate over longer distances, and it's robust
Exactly.
to real-world conditions.
And the paper actually does a very detailed comparison
Okay.
with other calibration methods showing how Click-Calib consistently does better, especially at those longer ranges.
Now we're getting into the technical stuff. So the paper talks about something called photometric error
Right.
and how it's not the best way to evaluate long-range BEV images.
Can you unpack that for us a bit?
Sure. So photometric error, it's basically measuring the difference in pixel intensities between those overlapping images
Right.
from the different cameras. So like ideally, if the images are perfectly lined up,
Yeah.
the pixels that are showing the same point in the real world should have the same intensity.
Right.
But in real life, it doesn't quite work that way.
Right, because you could have different cameras with different, like, exposures or lighting conditions.
Exactly. And when you're working with those long-range images,
Yeah.
those discrepancies become even more obvious.
Okay.
So you could have images that are geometrically aligned but still have a really high photometric error.
Just because of the differences in how those cameras are seeing the scene.
Exactly.
Interesting. So just looking at photometric error, it might look like the calibration is off,
Right.
when really it's just like the variations in the lighting
Exactly.
or the camera settings that are causing those differences.
Yeah. So to get around that, Click-Calib introduces a new metric. It's called mean distance error, or MDE.
Okay.
And this one directly measures the average distance between those key points you clicked on the ground
Okay.
and their actual positions in the images.
So instead of looking at like the pixel brightness, it's focusing on how accurately the system maps those real world points
Precisely.
into the image.
And this turns out to be much more robust to variations in lighting and how the cameras are set up. It directly reflects how well the system's understanding the geometry of the scene.
Got it. It's kind of like saying, okay, we know these points should be here in the image. Let's just measure how far off they are.
That's a great way to put it.
And that gives you a more direct measure of how good the calibration is.
Exactly.
Okay, so one other challenge that Click-Calib tackles is scale ambiguity,
Yes.
which the paper mentions can be a problem with camera calibration.
Right.
Basically, you can have different camera parameters that create images that look pretty much the same.
Yeah.
But they're at different scales.
Right. It's like how a miniature model of a car, if you filmed it with like really tiny cameras, could produce images that look similar to a real car
Oh, that's interesting.
with bigger cameras,
Yeah. So how does Click-Calib deal with that? How do you make sure the system knows what the real scale of the environment is?
Well, they fix the height of each camera
Okay.
during the optimization process. And this is actually a pretty smart move
Okay.
because you can easily measure the height of the camera in the real world.
Right.
And by fixing that, they're basically anchoring the scale of the whole system.
So it's like setting this one reference point
Uh-huh.
that prevents the whole model from shrinking or expanding.
Exactly. It's
Right.
like saying, okay, we know for sure the cameras are this high off the ground. Now let's figure out everything else based on that. Exactly.
Okay. That makes sense.
Mm-hmm.
That's pretty clever.
Yeah.
So that helps make sure that the system is capturing the real world dimensions accurately. Awesome. So we've covered a lot. I think we have a pretty good understanding of how Click-Calib works.
I think so too.
What do you think the bigger implications of this are? What does this mean for the future of surround view systems?
Well, I think Click-Calib has the potential to make calibrating these systems a lot simpler and easier.
Okay.
And that could save manufacturers money, make production faster, and ultimately make these advanced safety features more affordable
Right.
for everyone.
Yeah, that makes sense. Because as these systems become more common, especially with autonomous driving becoming more of a reality. Having a calibration method like this is going to be really important.
Absolutely. And it's exciting to think that an idea as simple as using clicks on the ground to calibrate cameras could have such a big impact.
It is. I'm really curious to hear more about what you think the future holds for Click-Calib. But first, we need to take a quick break. Stay tuned. When we come back, we'll be diving into our Novel Notions segment. We'll explore some really interesting possibilities inspired by this paper.
Welcome back, everyone. I feel like we just scratched the surface of how cool Click-Calib is.
Yeah, I'm still kind of amazed that a few clicks can replace all those complex calibration patterns and setups.
Right. And don't forget about how well it works even when things aren't perfect.
Yeah, the fact that it handles longer distances and those bumpy roads just makes it even more impressive.
It really shows how sometimes the most elegant solutions come from simple ideas.
Definitely. Speaking of simple ideas, I was thinking about those clicks. What if we could automate them somehow?
Ooh, interesting. Now we're talking novel notions. That's what I love about this part, taking a cool idea and seeing how far we can push it.
Exactly. So how could we automate that key point selection in Click-Calib? Any ideas?
I think we could tap into the power of computer vision.
Hmm, interesting.
Imagine a system that could just look at the camera images and pick out the best key points on the ground all on its own.
So instead of a person clicking, the system would find those points automatically.
Exactly. It'd be like having this invisible helper that's always watching and making sure the calibration is spot on.
That would be pretty cool.
Right.
But wouldn't that need a ton of processing power? I mean, analyzing all those video feeds and finding the right points in real time sounds intense.
It would definitely be a challenge. We'd be dealing with a lot of data, and the algorithms would need to be really robust, able to deal with changing lighting, shadows.
Right. And what about when things are blocking the view of the ground, like other cars?
Yeah, occlusions, that's another hurdle. But let's say we could solve all that and create a system that could reliably auto-select those key points.
Okay. And then what?
Well, think about what that could mean. The calibration process could become even faster and more efficient.
Yeah, you could potentially get rid of any manual steps.
Exactly. That would be a huge win for car manufacturers, right?
It would streamline the whole process so much. It'd be like the cameras calibrate themselves as soon as they're installed.
Exactly.
No more special setups or procedures.
And it wouldn't stop there. Think about the possibilities for autonomous driving.
Oh, right. Because those self-driving cars depend on these surround view systems so much.
Huge reliance. And if the system could continuously calibrate itself, adjust for any change in the environment or even small misalignments.
It would make those driving decisions even more accurate.
Precisely. And safer too, potentially. It'd be like having this built-in safety net for accuracy and reliability.
It's kind of amazing how this idea of automating the click started out so simple.
I know, right?
And now it's leading to all these possibilities that could really impact different industries.
It really is remarkable. It's a perfect example of how a research paper can spark these really interesting conversations and get us thinking creatively.
Absolutely. It shows the power of human ingenuity and how we're always pushing the boundaries of what's possible with technology. This has been so insightful. I'm excited to keep exploring these novel notions with you. But we're running short on time for this segment. Be sure to join us for part 3, where we'll dive into another fascinating possibility inspired by Click-Calib that could change how we interact with our cities. Welcome back to the deep dive. We've been talking all about Click-Calib and how it's changing the game for surround view systems.
It's been a really interesting discussion, hasn't it? From those simple clicks to the potential for automation. It's pretty amazing.
Yeah, it's definitely been mind-blowing. And in the last segment, we were talking about how we could maybe automate those key points. But I'm curious, what other novel notions has this paper inspired for you? What else are you thinking about?
Well, one thing that keeps coming back to me is what if we took Click-Calib a step further? Like, what if we didn't limit it to just the ground? What if we could make it work in 3D?
Whoa, okay, now you're really getting my gears turning. So instead of clicking on points on the ground, we could click on, like, buildings, trees, cars, anything.
Exactly. Right now, Click-Calib works because it assumes a flat ground plane. But the world is 3D, right?
Right.
And if we could bring those 3D features into the calibration process, we could potentially make it even more accurate and robust.
I see what you're saying. It's like going from a flat map to a 3D model of the whole environment.
Exactly.
The system would have a much better understanding of everything around it. But wouldn't that make the calibration a lot more complicated?
Oh, yeah, definitely. We'd be moving from those simple point correspondences to dealing with like 3D point clouds.
Right.
and all sorts of complex geometric transformations. It would be a whole other level of complexity.
Yeah, I can imagine you'd need some serious computing power for that. And some pretty advanced algorithms too, right?
For sure. We'd be diving deep into 3D computer vision, point cloud processing. We might even need deep learning to help with object detection and feature matching.
So, not an easy task. But let's say we could figure it out. What would the benefits be? What could we do with this 3D Click-Calib?
Well, for one, it could make those surround view systems even more accurate, especially in places with lots of tall buildings or uneven terrain. Think about a self-driving car navigating a city center with skyscrapers and parking garages.
Oh, yeah, that's a really complex environment.
Exactly. And a 3D calibration would give the car a much more precise understanding of where everything is.
It'd be like giving the car a super detailed 3D map of the city,
Exactly.
so it could make better decisions even in those tough situations.
Exactly. And think about the applications beyond cars. Robotics, augmented reality. We could have robots that can interact with their environment so precisely they could map everything and manipulate objects with pinpoint accuracy.
Wow, so this 3D Click-Calib idea could revolutionize all sorts of industries, not just cars.
Yeah,
It all started with clicking on a few points, and now it's branching out into all these amazing possibilities.
it really shows how research can have a ripple effect, you know? A seemingly small innovation can spark ideas in all these different areas.
This has been such an eye-opening deep dive into Click-Calib. Thanks for joining me on this exploration. It's incredible how research papers like this can spark new ideas and really stretch our imaginations.
It's been my pleasure. And to all our listeners out there, keep exploring these topics. Stay curious about how technology is changing the world around us.
Absolutely. Remember, the future is built by people who dream big and push the limits of what's possible. So keep thinking, keep exploring, and who knows, maybe you'll be the one to come up with the next groundbreaking idea.
Until next time, keep those minds active and stay curious.
See you on the next deep dive.